So in this problem, we want to find the partial derivative with respect to x and y, and then at these 2 points. Okay, so f of xy is defined as this rational function here. So in order to differentiate, we're going to have to use the quotient rule. Okay, so let's start with the partial with respect to x. So to find this derivative, we're going to treat y as if it is a constant. Still, even if y is a constant, we've got x's both in the numerator and denominator. So we need to use the quotient rule. So it is low d high minus high d low over low low. So low is the denominator, x squared plus y squared. D high is the derivative of the numerator. Now x is the variable and we treat y as if it's a constant. So the derivative of 2x squared is 4x to the first. And the derivative of 6y squared is actually just 0 because if y is a constant, then 6y squared is a big constant. So the derivative of a constant is 0. It's low d high minus high, we just copy the numerator. D low, derivative of the denominator, is going to be 2x. And then the derivative of y squared is 0 because we're treating y as a constant. All over low, low. So all over x squared plus y squared, all squared. You might be able to enter your answer like that, or I'm going to go ahead and simplify just a little bit and see. I think we'll have a little bit to simplify here. So distributing this 4x out on top would give us 4x cubed plus 4x y squared. Distributing this 2 out and this negative as well will give us minus 4x cubed, then plus 12x y squared, all over x squared plus y squared, all squared. And yeah, it looks like the 4x cubes cancel. And then we can combine the xy squared terms in the numerator. 4 plus 12 is 16. Okay, so that's the partial of f with respect to f. Now to find the partial of f with respect to x at the point -1, 1, part C, we would plug in -1 for x and 1 for y everywhere. So it would look like this. So in the numerator we'd have -16, and then the denominator, -1 squared is 1, so 1 plus 1 is 2, squared is 4, so it looks like we get -4. And the partial with respect to y has worked basically the same way. You just treat x as a constant and you treat y as your variable, and you'll get something pretty similar for those two answers.